Welcome to my audio article on Fred Lawrence Whipple, the astronomer who gave us a new way of seeing comets and helping usher in the space age. Fred Whipple was born in Red Oak, Iowa on November 5, 1906. His childhood was marked by illness and hardship. Scarlet fever nearly took his life, and polio left him with one leg shorter than the other, ending his dream of becoming a tennis player. Yet these early challenges only deepened his hunger for knowledge. He immersed himself in books from Edgar Allan Poe to H.G. Wells and tinkered with radios, chemistry sets, and mechanical models on the farm. In 1922, his family moved to California, and Fred began his studies at Occidental College before transferring to UCLA, where he majored in mathematics. It was there he discovered astronomy under the guidance of Frederick Leonard, and his life changed course. By the late 1920s, he was working at Berkeley and Stanford, and then at the famed Lick Observatory, where he studied under leading astronomers. As a graduate student, Whipple helped calculate Pluto's orbit shortly after its discovery in 1930, earning him early recognition. But his greatest contributions came after he joined the Harvard College Observatory. There, he not only redesigned telescopes to improve performance, but also began his groundbreaking work on comets and meteors. In 1933, Whipple discovered both a periodic comet, now known as 36P Whipple, and the asteroid 1252 Celesta, named after his mother. He proved that meteors were not interstellar visitors, but belonged to our own solar system. During World War II, he devised radar countermeasures using strips of tinfoil, the precursor of chaff, and later invented the Whipple Shield, a thin layer that protects spacecraft by vaporizing incoming micrometeoroids. This design is still used today on satellites and the International Space Station. But perhaps Whipple's most enduring legacy is the dirty Snowball model of comets. In a series of papers during the 1950s, he proposed that comets were icy conglomerates of frozen gases mixed with dust, not solid rocks or fragments, as many had believed. His hypothesis was dramatically confirmed when Halley's Comet returned in 1986, and the spacecraft images revealed the very structure he had described. As director of the Smithsonian Astrophysical Observatory from 1955 to 1973, Whipple oversaw some of the most exciting developments in space science. He organized Operation Moonwatch, a citizen science effort to track satellites, which was ready and waiting when Sputnik was launched in 1957. Under his leadership, the SAO built a global network of satellite tracking stations, providing key data about Earth shape and the gravity field. His work earned him the Distinguished Federal Citizen Service Award from President John F. Kennedy in 1963. Even after retirement, Whipple never slowed down. In 1999, at age 93, he was still consulting for NASA on comet missions. The observatory at Mount Hopkins in Arizona was named in his honor, a fitting tribute to a man who spent his life gazing into space. Fred Lawrence Whipple passed away in 2004 at age 97. His vision had spanned nearly a century, from the horse and buggy days of rural Iowa to the dawn of the 21st century space age. He had lived long enough to see his comet theories confirmed, satellites launched, and spacecraft protected by his inventions. Fred Lawrence Whipple once said that mathematics guided him into astronomy, where time, space, and physics had a common meeting ground. His life was the meeting ground, where curiosity met perseverance and imagination met discovery. Thank you for listening. I hope you enjoyed learning about Fred Lawrence Whipple, the astronomer who gave us the dirty Snowball and helped shape humanity's first steps into space.